Hello all, welcome back to my YouTube channel all about VLSI. Hope you're all doing good and I think my voice is audible and my screen is visible, right? Yeah. So let us start today's session. So today's session is continuation of the topic K-maps in digital. Okay. So let me share my PPT. Okay. So we have introduced with the K-maps in our previous session and we have seen how to form a K-map for SOP expression as well as POS expression. Okay. For SOP expression, we were grouping the ones and in POS expression, we are going to group zeros. That is the difference between the grouping of SOP expressions and POS expressions. Now, let us see the various implicants in digital. Okay. In K-maps, we will see various implicants. So first type of implicants are prime implicants, prime implicants, and second type of implicants we have are essential prime implicants, essential prime implicants, and the third type we have redundant prime implicants, redundant prime implicants, followed by the fourth type which are called as selective prime implicants, selective prime implicants. So these are all the four type of implicants we have in K-maps. So first one is known as prime implicants and second type is essential prime implicants, and third type are redundant prime implicants, and the fourth type are selective prime implicants. Now let us see one by one what are these type of implicants. So first type are called prime implicants. I'm denoting with them as PI. Okay. Now, so prime implicants are the implicants or a group of squares or rectangles made up of a bunch of adjacent minterms, which is allowed by the definition of K-map. Okay. Let us see an example of prime implicants by considering a K-map for SOP expression. Okay. Let's say this is our K-map for a three variable K-map. I'm drawing a three variable K-map. So a three variable K-map will consist total number of cells. How many number of cells? It will consist total 2 power 3, which is 8 number of cells. So a three variable K-map will consist of 8 number of cells. Now I'm drawing it. Okay. So it is a three variable K-map which is consisting of 8 cells. Okay. Let me select a random function. Let me place the ones in this particular cells. Yeah. So it is a SOP form of representation where I am considering only my minterms. Okay. Now here, how can I group? So this is first group. These two adjacent cells are one group, and these two adjacent cells are another group. Okay. So grouping should be done between the adjacent cells. Okay. Grouping should be done between the adjacent cells. This we have already seen, and this is also adjacent cell. Okay. Now, how many prime implicants are present here? So this is one prime implicant, this is one prime implicant, and this is second type of prime implicant, and this is third prime implicant. So total we have here how many prime implicants? Total we have three prime implicants. Okay. So this is how we are going to identify the prime implicants in a particular K-map. Okay, prime implicants are nothing but the group of squares or rectangles. Okay, group of squares or rectangles. This is one group, this is second group, and this is third group. Okay, so total there are three prime implicants. Now, let us see what is meant by essential prime implicant or EPI. Okay, let us see what is this essential prime implicant. So the implicants, these are subgroups or groups that cover at least one minterm that can't be covered by any other prime implicant. Here, the group which can't be covered by another group, which can't be covered by other group. Okay, the group which can't be covered by other group are known as essential prime implicants. Now let us take the same example which we have taken in the previous example. Okay, let us take the same K-map like this, and let us write down the minterms here. 1 1 1 1. Okay, so how many prime implicants are there here? As in the previous example, we have seen how many prime implicants. So there are total three prime implicants. This is one prime implicant. Okay, this is one prime implicant, and this is another prime implicant followed by this one. Okay, this group is another prime implicant, which we have already seen in our previous slide. But in the case of essential prime implicants, here we should not. So how many essential prime implicants are there here? Two. Why? This is one essential prime implicant and this is second essential prime implicant. Now we cannot form this. We cannot form this group and say it is a essential prime implicant. Why? Because it is already covered. This group consists of all the possible minterms, and this group is also consisting of all the minterms, and this third group is overlapping between these two groups, so it cannot be said as a essential prime implicant. Okay, the group which is covering the already covered groups, okay, this third group which we are forming now as a prime implicant is covering the previous groups 1 and 2, so it cannot be called as a essential prime implicants. So total number of essential prime implicants here are EPI are equal to 2. Okay, so here essential prime implicants are equal to 2. Okay, essential prime implicants always appear in the final solution. Okay, essential prime implicants will always be occurred. The minterms which are involved in the essential prime implicants will be seen in the final result also, whereas prime implicants which are present here, the minterms which are involved in the prime implicants will not be is not necessary that they will be present in the final result. Okay, now let us see one more type of implicants which are known as redundant prime implicants, which are known as, one minute, the third type of implicants are known as redundant prime implicants, or also known as RPI. Okay, so the redundant prime implicants, the prime implicants for which each of the minterm is covered by some essential prime implicants, are redundant prime implicants. Now let me repeat this definition again. The prime implicants for which of its minterm is covered by some other essential prime implicants are known as redundant prime implicants. The prime implicants can never appear in the final solution. Now let us see what are the redundant prime implicants here. Let us take the same example of a 3-variable K-map, which is consisting of total 8 number of cells. Now, here these two are essential prime implicants. These two groups are essential prime implicants. These two groups are essential prime implicants. And now the third group here, this group is known as redundant prime implicant. Redundant prime implicant. So this is not useful. Okay, this particular group is known as redundant prime implicant. This type of grouping is not useful here. Okay, so this type of prime implicant here, this type of prime implicant is known as redundant prime implicant. Now let us see one more type of implicants, which is known as selective prime implicants, or also known as SPI. Okay, selective prime implicants. Now let us see the same K-map. This is our K-map, which is consisting of 8 number of cells, and let me write down the minterms 1 1 1 1 1. Now here we have essential prime implicants. This is one essential prime. First let's see the prime implicants which are present here. So this is one prime implicant, and this is second prime implicant, followed by this one third prime implicant, and this is fourth prime implicant. So how many prime implicants are there here? So here there are total 4 prime implicants. Okay, you can see the 4 groups, right? So the total prime implicants present here are 4. Okay, so this is one group, and this is second group, and this is third group, and this is fourth group. Now here there is nothing such as redundant prime implicant. If you see carefully the grouping done here, I will draw it one more time. 1, 1, 1, 1, 1. Now let me draw the essential prime implicants first. This is one essential prime implicant. If you group like this, it will become a redundant prime implicant, so I'm not involving that. Now here you can group this two and this. Okay, this is one way of grouping. Now same like this, you can also follow another type of grouping. Let me show you. 1, 1, 1, 1, 1. Okay, you can group these two. These are essential prime implicants, and here you can group these two. Now this here, in the previous case, you have grouped these two adjacent cells. Okay, so in this case, what you can do, you can group these two particular adjacent cells. Okay, you can group the vertical cells present here, or you can group the horizontal cells present here. Okay, here in this particular example, there is no redundant term at all. Here, the type of implicants here are known as selective prime implicant. That is, it's your choice which type of grouping you can select. That type of grouping here, it is a selective prime implicant. So this type of implicants are known as selective prime implicants. Okay, so these are the different type of implicants which are present in the K-maps: prime implicants, essential prime implicants, and redundant prime implicants, and selective prime implicants. Okay, now let us take some examples and analyze this type of prime implicants. Let us say if we have a function sigma 1, 5, 6, 7, 11, and 12, 13, and 15. Okay, now we have to find the prime implicants, essential prime implicants, and redundant prime implicants, and selective prime implicants. Okay, now it is a 4 variable K-map, so total number of cells are equal to 16. Okay, let me draw that K-map. This is 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. 1, 5, 6, 7, and 11, 12. This is 12. Okay, 12, 13, 15. Okay, so we have the minterms present here. Let me change the color now. So let's see the number of implicants first present here. This is one type of implicant which is present here, and this is another group we can form, and this is one more group we can form, followed by this is here not present, yeah, this two group. Okay, and we can also form a quad here, 4 type of grouping. Okay, 4 cells we can group, 4 adjacent cells we can group like this. There are total 1, 2, 3, 4, 5. Okay, so total prime implicants present here are equal to 5. Okay, so there are total 5 groups present here. So total prime implicants present here are equal to 5. Now let us see essential prime implicants. Total number of essential prime implicants present here. If you observe, this is a essential prime implicant. Okay, this grouping is necessary. Okay, and this also is an essential prime implicant. This group is necessary, and this is also an essential prime implicant since this grouping is necessary, and this grouping is also essential prime implicant since it is necessary. And this quad, which is grouping 4 minterms, is now covering the previous groups. Okay, so it will become a redundant prime implicant. I will change the color. So this quad is a RPI, redundant prime implicant, and it will not come under essential prime implicant. So total there are 4 essential prime implicants. Essential prime implicants are equal to 4. Essential prime implicants in this particular example are equal to 4, and redundant prime implicant is only one redundant prime implicant, that is this one. This is a redundant prime implicant. So like this, we are going to find out how many prime implicants, essential prime implicants and selective prime implicants are present in a particular K-map grouping. Okay, yeah. So these are all the various implicants which are present while we are grouping min terms or max terms in a K-map. Okay, now. So minimization of SOP expressions. Now let us see what is this minimization of SOP expressions. So first step is to construct the K-map as we have discussed and enter one in those cells corresponding to the min terms. Since for SOP we will group ones and we will place zeros in the other cells and form the groups of possible is as pair, quad and octet. Okay, then there can be overlapping of groups if they include common cells. While doing this, make sure that there are minimum number of groups. Okay, so we should always follow the minimum rule. Okay, there should be only minimum number of groups which should be present in the midterm, which should be present in the K-map, and we will circle the cells which contains and are not adjacent to any other cells, and these are known as isolated minterms, and they appear in the expression in SOP form. Okay, this is not SOP form. 1 minute. Yeah, so this is how we are going to form a K-map, and we are going to minimize the SOP expression using the K-map. And for PO, and afterwards we will write the Boolean term for each group and obtain the minimized expression by summing the product terms of all the groups. Okay, so this is how we are going to simplify a Boolean expression using the K-maps. Okay, so yeah, so that's all for this session. So in next session we are going to take some examples of Boolean expressions, and we are going to solve them using the K-map techniques which we have learned so far. Okay, so that's all for this session. So if you like this video, please like, share and subscribe to our YouTube channel all about VLSI. Thank you.